All right. Welcome everyone to episode 25 of DocumentDB Insider Hour. So good morning, good afternoon, good evening. Appreciate you taking some time out of your day to join us here. And with me today, I've got Wan Shen, and the topic we're going to cover is around using database migration service with Amazon DocumentDB. So just to set the stage a little bit, so I am a DocumentDB specialist solution architect, so work with a lot of customers, especially helping them get started and working with DocumentDB. And many times those customers need to migrate data from an existing database into DocumentDB. And that's what Wan Chen is going to be diving into with us here today. So with that, Wan Chen, I'll turn it over to you and we can get into the discussion.
Hi, thank you so much, Douglas. My name is Wan Chen, and hello everyone here. So I'm a solution architect, database specialist, especially for partners. I'm particularly focused on DocumentDB and Aurora open source based databases. And also I'm a subject matter expert in database migration service. So this is our topic today. We're going to deep dive into how you can leverage DMS, which is database migration service, to migrate to DocumentDB. Glad to have me here.
Yeah, no, great. Yeah, we've got the expert here to to talk to us about this today.
All right. So when we have a sort of a migration project, we may think about database migration service a lot of time because this is mainly easy to use. You can just click through and get the database ready to migrate, and you can view a lot of status and the logs and metrics and get track of what is going on, the progress of the migration. This is mainly being utilized by a lot of our customers. DocumentDB is definitely one of the target it supports. So today we're going to talk about how exactly we can leverage DMS to migrate to DocumentDB. So before that, we definitely have different options, right? So first of all, we have the offline migration methodology. You basically use MongoDB utilities, let's say dump Mongo restore, but the caveat of doing so is offline, right? So you dump the data and restore to the target. It basically means you're going to have the source database paused in order to migrate the current data, other than having a live database in both ends, right? So this is the reason why there could be a long downtime during the migration. You have to pause the change from the source in order to have the target up to date. So the way that we say DMS can be online is because it doesn't only support full load, which is dump and restore. You can think that way, it is logically dump and restore, but also it supports CDC, which is capturing the ongoing changes, right? So you can keep up to date with the source changes in your target database. And in the meanwhile, you can definitely test using DocumentDB clone, which doesn't have the impact to the database that you are currently migrating to, right? So you can leverage the clone to do a lot of tests and having the data up to date as well during the migration. And when you're ready with your testing, and then you can switch over, right? So this is the second approach, which is today's focus. And the third one is basically you leverage both of them, right? Because DMS supports CDC, which is capturing the ongoing changes. You can leverage the offline, which is dump and restore, and then use DMS CDC to keep the data up to date.
Right. Yeah. And really the reality is, I'm going to say in the vast majority of cases, you are going to have to do an online migration of the data. All right. You're probably not going to be able to take an outage, right? Unless it's a relatively small amount of data, you might be able to do it in an outage window. But the reality is most customers need to do some sort of online migration, and database migration service or DMS makes that really easy.
Yeah, definitely. So this is the holistic steps typically when you are using DMS. So basically, you were going to point the database migration service DMS to your source database, and also you need to have a connection to your target database, which is DocumentDB as well, right? So you establish the connectivity. And also, basically, you need to do the index import first. This is one of the best practices during migration because of the overhead after have the humongous data loaded. After you do that and then create the index, the overhead can be definitely even higher than you have the index in place, right? So you're going to import the index and basically remember to skip the ones that you don't basically use, right? So you can save the space and improve performance at the same time, right? After the index got restored to the target, and then this is the time that you can do the data migration utilizing DMS. DMS mainly focus on the data itself, like migrating whatever the data and the changes, right? It doesn't touch the schema, basically your index, right?
Right.
And once you have done testing the target, let's say the performance is good, the feasibility of your application is good, right? And then when you're ready, you can just switch over to the target when the CDC latency is 0, right? So that way you have the minimum amount of the downtime.
Cool. And yeah, the you mentioned here and on the diagram the pre-create indexes as optional. All right, when I'm talking to customers, I'd say it's not optional. I mean, yes, you can create the indexes after you migrate all the data, but like you said, and one thing a lot of times what folks don't realize or don't think about is if you've got a really large data set, creating multiple indexes on that really large data set can take a very long time because just sort of sequentially processing all of that data, building the indexes. Whereas if you create the indexes ahead of time, right, all of those indexes can be built in parallel as the data is loading. So
Yep.
ultimately, it's going to be done much quicker. So yeah, and the other thing is, right, a lot of, like you mentioned and pointed out, a lot of folks don't realize at first that DMS is just the data, right? It doesn't migrate indexes, so you do need to take that step.
Exactly. So with DMS, one benefit I will say it is convenient, right? So you just point to the source and point to the target and let DMS to handle the bulk load as well as the changes, right? So in that way, it is kind of convenient. It is fully managed, so you just click through the console and you get the data migrated. In the meanwhile, for especially for the full load phase, right? So if you are loading a lot of data, definitely there will be some resource to be utilized. If you do have good enough resource in source and target and also the replication instance, then you can increase the parallelism so that you can improve the bulk load performance. This is also being true that if you do Mongo dump and restore, right, you can increase the number of the jobs loading together. But before that, you should have the good enough resource.
Right. Yeah. Another great point. Right. A lot of folks I talk to may not realize there's options to tune that, and just using the default, it's a single thread just chewing through all of that data, which is going to take a lot longer than multiple threads. So yeah.
Yeah. We will definitely take a look at how that can be set up in a little bit. But before we do that, two other points that I wanted to emphasize. This is DMS does support CDC, which is you can point the DMS to a certain timestamp to say, I want to migrate the changes from this point of time, from the source MongoDB. So you can also do that. That means you can use your favorite bulk load method and then use DMS to capture the changes. And another thing is DMS support migrating different databases via one task. So you don't have to basically point one database per task, even though you can do so by leveraging more parallelism. But if we're talking about small database, small MongoDB, you can use one task to migrate multiple databases and multiple collections within them.
Got it. Okay. So yeah, it becomes simpler to manage then if, like you said, depending on the size and the amount of that data in the source. single task can simplify.
Yeah.
Nice.
So moving along, this is an illustration on how parallel load basically works in DMS. So basically speaking, you're going to choose segment the data from basically a source large collection, right? And segmenting can be done automatically either by DMS or you can do yourself, right? You can say, I just want to segment the data based on a particular key or ID or whichever the identifier that can be uniquely identify the rows, the documents in the source database, right? And each segment will be handled by each subtask within DMS. So you can specify the number of the subtasks running together in DMS, right? Since we have one-to-one mapping, one segment, one subtask, another segment, another subtask, right? So you want to make sure that the number of the segments roughly equals to the number of the subtasks. It is being okay, you can have more segments, of course you can do so, but those segments that without a handler yet, right, it can definitely be queued up. Right, so this is
Okay.
how it is, right? 1 to 49 and then 50 to 98, right? So another run, and the subtask is free to handle another.
Got it. Okay. Okay. Yeah, that's an important thing to understand there. So yeah, that's
Yep.
cool.
So definitely we have two methods in terms of the segmentation of your source data because it's large, right? You want to segment your data or partitioning your data evenly so that you can fully leverage the subtasks to load the data in parallel, right? Imagine you just have one document in segment 1, you have a million in segment 2, you have 2 billions in segment 3. So basically, like it is a waste of the resource in segment 1, and the segment 3 and 2 could be super hot, right? So you are not basically leveraging parallelism. So the principle behind this is segmenting your data evenly. This is how automatic segmenting by DMS is targeting to do. This is just segmenting your data evenly.
Got it. All right. So it sounds like I'd probably just want to let DMS segment it for me. So under what scenarios would I want to say choose or specify my own segments?
Yeah, so leverage EMS is definitely good because it's convenient, but it definitely has the cons part. It will need resource so that it can evenly distribute its data, right? So it can definitely conduct a sort. It will use the resource in the database end and also DMS to be able to specify the boundaries for you. So this is the cons. It can definitely use the resource. However, if let's say you want to specify some other field to be segmented to, let's say DMS is only segmenting by underscore ID, but if you choose to use another field to segmenting your data make more sense to you, then you can use the segmentation manually specified. And you can also choose to have multiple fields to do the segmentation as well. So this is the pros for manual segmentation.
Got it. Okay. So I guess as a good approach, just start with auto, all right? And if the
Yeah, how it goes.
performance is good, just stick with that. If you see it's not performing as you expected it would, then you might want to look at manual.
Yeah, that's
Okay.
true.
Okay. Cool. Thanks.
Yeah, so next we'll take a look at my DMS console and see where to specify those. Okay, so first of all, this is my task. When I'm going to specify the segmentation, it is in the table mapping section. So where you can do it is you can switch to the JSON editor and then editing your table mapping, which is under table setting rule. And there is a particular field called parallel load, and you can specify the number of the partitions, and you can say how many pages how many records in maximum to skip per page. What we do is we are trying to eliminate the duplicates to read before we can get to the particular partition, right? So this, if you set this high, which is good, we can skip that. If it is super low, then we're going to back and forth more times. And byte sizes is basically the size of each partition to read from. So here I specify I have 2 partitions to let DMS to segment 2. So in that way, I will need to check if I have the subtasks to handle those many partitions that I'm going to specify, right? So where I can find the subtasks, it is under JSON editor again, and you're going to find it here. The maximum full load subtasks. So by default, it is 8. So 8, it is larger than 5, right? Definitely. So it means that I have good amount of subtasks to handle my segmentations. If, let's say, I wanted to segment into 100, then 8 is not good enough. It will be 8 per time, and another 8, and another 8, until 100 segmentation is handled. So this is where that I can specify the maximum tasks.
Okay. That's a good call out. So need to check, specify the number of segments, and this is where we check the subtasks. Okay.
Yep. So this is where I can set this the parallel load and segmentations, right? Once it is loaded, I can basically go ahead to check my CloudWatch logs, and I can see the segmentations got loaded together. So basically, I already filtered that out. I can see I have 5 segmentations, right? This is what I specified. And then I can see for each, it load this many rows and this many data. And then I can see it take this much time, right? It is super quick because I don't have data humongously, obviously, but you can see the timestamp is like loading together, right? So for each, this is taking this amount of time, and basically means that for those many loading together, it is this amount of time roughly, right? Other than you load them together, and this time could be times 5.
Right.
Roughly.
Okay. Yeah, but that's, I mean, what you've got highlighted there, I think is really interesting, right? Because DMS does a lot for you, but it's also showing that it's very fast, right? I mean, 10,000 microseconds is very fast. So certainly the more data you have, the longer it is going to take. But the thing is like DMS looks like it's not adding a lot of overhead to the process here.
Yep, the beauty of parallel loading is you can leverage the resource that you have and make DMS do the job and then load the data faster, right? So just wanted to emphasize, because I don't have so much data, right? I can definitely, sort of specify many segments that I have. But supposedly you have 2 billions of data, several billions of documents in the source database, right? And you want to specify, let's say, 10 segments or maybe 100 segments loading together, which is great. We can definitely do that. But pay attention to, if you do have 100, virtual CPUs, source and target, right? That means that 2 billion document divided by 100, those many documents will be loaded together at once. So pay attention to the number of the virtual CPUs that you have.
Yeah, no, that's a great point. So yeah, there's definitely don't just pick, don't just use the maximum number, right? It's you got to do some investigation and determine what is the best number of segments based on the size of my documents, the number of documents.
Right. So moving along, we will take a look at if we can do migration using DMS from relational database. So why we may try to do so? Because there are times that you want to use JSON-based document, right, to suit for your particular application needs. Many times, we have been seeing customer, having the relational database, but it is like too much to do to, basically extract the data from multiple tables all together and generate the report and having nested structure between those, right? It is like hard to do in relational, but naturally speaking, DocumentDB is designed for that type of query. So what you can do to leverage DMS to do this type of migration, it is that you can migrate from views, right? So in source database, definitely you have relational structure, basically using foreign keys to link multiple tables together, right? So in the target end, in our DocumentDB, so it can be a denominalized data structure, right? So basically you can leverage views in your source database and use DMS to migrate from view and then to the target DocumentDB. But pay attention to that. If it is a logical view in the source, then DMS can only extract the data, basically like ETL kind of workload utilizing full load, but CDC ongoing changes, it would not be captured. But if it's materialized view in the source, then definitely DMS has no trouble to capture the changes for those materialized views.
Wow. Okay. Yeah. That's awesome. Yeah. Talked to a lot of customers migrating from relational as well, and it's this capability is extremely helpful with that. Yeah, and we could easily get off into a whole data modeling discussion, but that's not the purpose of this. But right, the point is, if you know what your denormalized data model is going to look like, right, create appropriate views in your relational database, and then DMS can easily migrate all that data for you.
That's true. But speaking on that, DMS does not only migrate views from a relational database, it can just migrate the table as is as well to DocumentDB. But pay
Even
attention.
better.
Yeah, right. So if let's say you have a table that is very transactional, a high amount of changes, and you do have some large objects into, let's say, binary data into that table, pay attention to that DocumentDB, the size of the document, right? And the log data, potentially you don't want to store in DocumentDB because, it will definitely occupy spaces. You may not even need that log binary data to be in your report, right? So you may not need that. So pay attention to the columns that you want to exclude from this migration.
Right. Yeah, great point. Yeah, it goes back to, I think you touched on it really early on with the migration about indexes, right? You don't want to move indexes you don't need. Same thing. Don't migrate data that you're not going to need. So yeah, do take the time up front and really understand your source and what you want to move.
Yep, exactly. So moving along, once we have the tasks running, we have the data migrated to the target, and we are looking at the progress, and we wanted to see, first of all, the matrix on how the performance looks like, and also if there is some particular error we wanted to troubleshoot, right? So this is going to help you on what you can deal with during the migration. Definitely migration can be intensive. There could be a lot of things going wrong, and this is definitely the reason why we wanted to do POC, of course, right? So we wanted to eliminate those errors, especially the ones that related to prerequisites, related to permissions, related to the things that we can avoid, right, ahead of the time, right? So those are the things that we need to prove what the fix is, and then we apply those fixes before we run into production run, right? So this is basically the requirement for POC. The one that I'm listing here, it is kind of a map, what can go wrong, right? So this is the mental map on what can be potentially going wrong and what is generally the directions to go. So
Got it.
mainly speaking, you have the infrastructure related missing prerequisites. Like I said, this is well documented, but at the first time we may miss something, and also the endpoint native error. Let's say if it's a database that I cannot access to, definitely I cannot migrate anything, right? So you're going to see a permission error there. And then if there's any limitations that well documented, we definitely need to be aware of them. And direction of the fix is basically performance tuning related. One we have already shown a moment ago, parallel loading, right? So other than that, performance also means resource. How much resource we have source and target. If the replication instance is large enough to handle the workload, and the other direction will be if there is some data got missed. So definitely we'll take a look at the logs, the control tables. We will talk a little bit later. So those are the ones that we can rely on to review the data related issues.
Got it. And I do actually got a question here. We'll take, and I apologize if I pronounce your user ID wrong, but I'm going to say Kylie3092 says, do I need some special permissions on source database to access the log tables? I think that DMS needs to access these log tables.
Yeah. So quickly, what you can do is you just search the DMS documentation, like what I'm doing right now. It has all the information that you require to basically achieve a full list of the prerequisites. So when you land to this page, you basically can see the prerequisites listed here, right? So one of them is the permissions. Permissions definitely means that you need to have the data to be able to read your OP log, and also you need to have the read permissions to read your data. So basically, those are the users you need to create into your source database.
Got it.
Take a
Great.
look at this page, and you can definitely see where you can go. I mean, for the permissions. But other than that, there are some other things that you need to configure, right? Let's say, for example, if the source is a standalone MongoDB, you will need to make it a replica set so that you can have OP logs, right? And also other things like you need to understand which is the authentication method, so that you can let DMS to do that, to do the same, specifying either two. But most of the time, we leave it as a default for utilizing this method if you're migrating from 304.
Got it. All right. Thanks. Thank you, Wanchen. So, sorry, I was getting that link to put in the chat here. Back to this, you mentioned a couple of times testing, right? So again, you're working with a lot of customers migrating, and that's one of the key. It's like I can't say it enough, right? Test, right? You need to there's a lot of pieces, right? You're not only testing the functionality and the performance and the correctness of the app on DocumentDB, right? But you're also testing the actual migration and, all right, do you have it segmented correctly? Do you have the right instance sizes and things like that? So definitely don't don't take any shortcuts on the testing, because doing all that final prod migration is going to go smoothly then.
Right. Testing is definitely one step you just cannot skip. Other than, testing, you may potentially skip the segmentation, do it manually. You don't have to do it manually. You can let DMS to do automatically. That step you can skip, but testing definitely is the most important thing, so that we can understand if the target is good to you, good enough for your application in terms of the performance, right, in terms of the visibility, right, and also how migration can be done. Here we show many tools for you to monitor your task. So this is the first tool that you can leverage. It is CloudWatch Matrix, right? So you can leverage the matrix to keep eye on definitely the resource utilization. Memory is super important in DMS because you just want the data come and go, right? You don't want to save the data into the disk and retrieve the data from the disk. It can definitely add up the overhead, right? Memory utilization is definitely the key. You want to use up the memory as much as possible. But if you see it is using up too much, like zero available memory, then it is the good time. You don't want to approach to zero. You want to have good enough resource for DMS to be able to handle the job quickly, right? Also, pay attention to if you're increasing the parallelism to improve the performance, right? So definitely you need to give more memory to do the job. So memory is important. The indicator if you have sufficient memory in the replication instance, it is the swap, right? Swap usage. If you see high swap all the time, it is being swapped back and forth, right? It is indicating memory is not sufficient enough. Ideally, swap should be zero. This should be zero all the time, and memory should be utilized a lot, especially during full load phase, right? So full load phase, if you do a lot of parallelism, then memory will be definitely used, as well as sometimes disk as well, because if it's too large to hold into the memory, it can definitely save to the disk.
Right. And it's trade-offs, right? In college, my freshman year computer science instructor said it's all about trade-offs.
Mm-hmm.
Right? So yeah, and this is a great example of that, right? You want ideally swap to be zero, but on the other hand, all right, the trade-off is scaling up to a larger instance. And the reality is that there is more cost associated with larger instances just to get to zero swap. But you're still migrating in the window where you need to perform the migration, even if there is some swap. So yeah, definitely important to watch these metrics to help you understand when you might need to scale. But yeah, it's all about trade-offs. There's a
Yeah,
lot of
you're right.
a lot of knobs and a lot of options here. But yeah, it's good to understand
Mm-hmm.
what those options are.
Mm-hmm. Yep. So in terms of the disk utilization, the end goal is still we wanted to minimize the disk usage, right? What we want to use memory as much as possible, but this is also being okay to use disk. So one indicator of this utilization is the free disk, right? So free storage space. If you see this is being utilized super much, like you are using disk,
Mm-hmm.
this is not good thing to do, right? It basically means either you have too much logs. We have different levels of the logging. If you have debug logging all the time, right, it will definitely use up your disk.
Mm-hmm.
And logging is designed to store into the disk, not your data, right? The data is come and go, right? The disk your logs will always be in your disk unless you delete it, right? So pay attention to this, the free disk, right? So you can also see from the disk queue depth, basically means that if you have a IO throttling, right? So if this is being super high, either it is because of too much data loading in parallel, or it can just because of you have too much logs.
Mm, okay. Yeah. So
Mm-hmm.
that's yeah, a lot of good information there. So a lot to keep an eye
Yeah,
on.
a lot of things to watch on.
Yeah.
But in a little moment, we'll see how we can put it together.
Okay.
Yeah.
Perfect.
So other than this resource utilization, right, in your replication instance, so that you can decide whether or not you need to scale up or you need to scale out, right? Some other things during replication is being the CDC latency. I didn't show it here, but CDC latency is one key metric that you want to be alert on. If it is like linear increasing, definitely it indicates something goes wrong, or the resources is too limited to handle that much workload, or there could be a long change, could be a bulk load to the source, so that DMS to capture them all until the change has been done in the source in order to make sure all the changes captured and then shift together to the target. So you can probably see linear increasing CDC latency during some bulk load in the source. So CDC latency is one important thing that you want to watch out too. Another metric is called CDC incoming changes. It is indicating something is queued up into the target end, basically waiting to apply to the target. So CDC incoming changes is another important metric that you want to be alert on. So those are the things that you can definitely rely on for monitoring how the progress looks like during your migration.
Got it. So in case of say CDC incoming changes, if I see that continue to grow, it sounds like that
Mhm.
would be a good indicator to scale up
Yeah.
the force. Sorry, the target, the target
Yes, the
instance.
target. Yes,
Yeah.
something is queued up. Either it is just a long change, or it could be too much changes, right? Too many changes. So as long as it's queuing up, this is a good chance to take a look at what's going on in the target, right? What's
Yeah.
going on in the target. Also, you can rely on CloudWatch metrics, right? You can see is I/O being waited for. It is basically because of the less of memory or CPU that you need to scale up, or it is because of, like, let's say locking, right?
Mhm.
Right. You can see the indicator from Performance Insight in the DocumentDB. Performance Insight is, I will say, it is a great tool
Oh
for
yeah.
you to, basically take a look at the waiting ones and top queries, right? So you can basically get a clue from there in the DocumentDB end.
Yeah. Oh, that's a great call out. And yeah, I know we're not going to go into performance insights here, but you know, for
Yeah.
folks listening or watching the recording, yeah, if you're already familiar with the performance insights, great. If not, I'll just do a quick plug. Right, it's a really easy way to visualize the load on the database. You'll load from specific databases in the cluster, from specific applications, from specific hosts, or specific queries. Like, so in this case, if you're using performance insights, right, you could quickly zero in and look at the load basically that's being generated by DMS inserting
Hmm.
and updating the target database, and kind of keep
Yeah.
an eye on it that way as well.
Yeah. So other than the CloudWatch matrix, another tool that you can definitely rely on is the CloudWatch Logs. So DMS definitely generate the logs, like the ones that we saw a moment ago, right? You can see the segmentation information, and
Mhm.
also you can see many more information from the load, right? So it is basically every step that is happening during the migration, right? So you can see, I'm just pointing something up, right? So it is like, this is the component called performance. You can basically see the performance related info, the statistics for the load, right? And also uh, it has source capture component. It basically capturing the changes from the source. So this is relying on, the source component to basically capture the changes. You can see what's going on there. And also it has, let's say this is the target load. Basically it is the load to the target. And here it is just showing me the version of my MongoDB compatible version, which is my DocumentDB. It is compatible with 4.0, right? So this
Mhm.
is what is happening into the target. Many details here into the log. But still, pay attention to the logging level,
Mhm.
right? We said a moment ago, if you have too much log, then definitely it is occupying the space into the disk, and it can be, like full, right? It will be breaking your, basically breaking your application. Uh, Normally speaking, default level, the logging level, default right here, this is already good enough for tracking purpose, right? But what if we are in troubleshooting mode, right? So definitely you can make it higher. I mean, the logging level can be definitely higher. Debugging logging level is definitely very helpful to track down what exactly the issue is. All you have to do is just use this drop down list and switch to this debugging log mode. Okay.
Nice. Yeah, I like that. Got a lot of pretty granular, right? You can get pretty granular with that and really what you want to log. So that's nice.
Yeah. So when you try to, let's say, debug, right? So it is related to target load. You can just switch this target load to debugging level. You don't have to switch them all. We can see there are many other components, right? This is being logged, right? So you can just increase the logging level for the relevant component. And also you can just use CLI to, increase the logging level while the task is still running. You don't have to stop the task and do the level, the level. You can just let CLI to change the level while the task is still running.
Got it. Oh, I see another question here real quick we'll address from Perry Essentials. Is it not possible to store DocumentDB logs in S3? And this is my first exposure to DocumentDB. So, well, thanks for joining us, and glad to hear you've got some interest in DocumentDB. But to the question, so internally, DocumentDB stores everything. In a distributed storage volume that you don't have access to. Now, certainly you can export data and even use DMS to migrate data from DocumentDB to S3, right? But the service itself, right? It doesn't store anything to S3, and it doesn't store it anywhere that you can have direct access to it without, say, exporting it and then putting it into S3.
Yeah, just to add that up, you can export your logs either from DMS or DocumentDB to CloudWatch Logs, and CloudWatch Logs definitely have the feature to export to S3. So from the CloudWatch console, you can basically use or use CLI to do the filtering. Or to do the inset. The inset is like SQL-like statement to extract the logs from CloudWatch. Also, you can have the export to, from CloudWatch to export to S3 for your other purpose of the use. But normally speaking, for, let's say, tracking purpose or for, you know, troubleshooting purpose, searching from here is I will say it is already good enough for see the errors, see what's going on. But definitely you can use CloudWatch export, that function, to export from CloudWatch to S3.
All right, thanks, Wanshan.
Sure. So other than the CloudWatch logs and matrix, we also have the DMS control collections. So the collections, basically, it is created by, those are the collections created by DMS for monitoring and tracking purpose. So for example, this is the collection that I migrated to my target DocumentDB. Other than this one, I have some other collections being created, right? So the first one is the apply exception. This is mainly recording the failed statement being executed in my target. So mainly speaking, you will need to keep an eye on, definitely an eye on this collection to see what exactly the failed query that has been executed in my target, right? So this has been very helpful to see the timestamp and the exact statement and the exact error got failed at from this particular collection. It is being created by default. You don't have the option to turn it off because it's too important. Those three collections, the histories, the status, the standard suspended tables, those three are optional. You can, depending on your need, you can turn it on or turn it off. So where you can do that, it is also through DMS console and in the advanced settings, right? So you can see this is grayed out. You don't have the option to turn it off. But the other three, you can basically turn them on, right? So you can turn them on to have those info. So what exactly the info is? In the status tape collection, in the status collection, basically it is just recording the status, especially CDC. Full load, yes, but CDC status is more interesting. Why I'm saying interesting? Because you have more data points on what's going on in terms of the replication, including the timestamp where DMS is replicating at, and also the timestamp on where DMS is replicating acknowledged back, right? And also you have the memory consumption information for that task. You can utilize this info to basically scale your replication instance properly. And also you can use the information from here to maybe create another task to resume from a previous state. So replication status, this is a collection that you can have more details in terms of the replication status, right? Suspended table, it is a collection to record the table, or here it is the collection itself got failed to load due to whatever the reason, right? So for example, typically speaking, if you have a sharded collection in the source database, right, and you haven't got a chance to basically clean your orphan documents, if any, then probably you're going to see some collection just got failed because of the duplicate keys, right? This is how it can go in your workload phase, right? So in this case, you are going to see table error in the statistics, right? So here it is loaded properly, so I see just the table completed. But if there's a suspended table, you definitely will see a table error right here. And also it will be recorded here in the suspended table.
Yeah, I've seen that too many times in my own testing. I forget to clear out the data, as I'm testing, and I forget to clear out the data and conflicting IDs. So yes.
Right. It is very typical use case that we have been seeing customers. I mean, this is very helpful to see which table or which collection got
Yes.
errored out with a particular timestamp and the reason. But it is still being, let's say, one of the best practices to just clean out the often documents before we just load and find it out. This is errored out. Okay, the next one is the history. History is nothing but the history, right? So it is the history of the replication. So it is recording the number and the volume of the records being processed during the task. And also it has some other helpful statistics. All this info, you can search DMS documentation. This is under control tables page. So it has more details about the data structure for each every table.
Awesome.
And putting all those together, we have been talking about too many tools already, right? We have the logs, we have the matrix, we have the different collections, right? So this is the way that you can put it together. Put it together, I mean to say, definitely you can leverage other services AWS provide to automatically monitor the status of the replication for you. So for example, you can utilize the CloudWatch Logs, the matrix, to create a CloudWatch dashboard, right? CloudWatch dashboard, it is the one to give a view, holistic view on what is happening. So I create my own dashboard. I have so many dashboard. Let's say this one. So I create this dashboard to just give my holistic view on CPU utilization, memory, the ones that we talk about very important, right? The free storage and also the migration workload. This is being the data transfer in and out, right? And also I can keep an eye on the status of my replication, right? And this is aggregator on the load status, right? So this is where I can see the holistic counts. I have nothing going on, so everything is 0. But in your particular console, you can basically see, okay, there is some particular collection got errored out. I need to take a further look at that, right? Other than that, we have per task utilization for the replication instance and the task, right? So you can see the latency as what we talked about. This is very important for you take a look at the progress, and you can just rely on this particular matrix to see if this is the good time to fill over to your target DocumentDB, right? And also the ongoing changes, the CDC incoming changes waiting to apply to the target, right? So this is a a holistic graph that you can see the progress. And also you can extract the logs from the target database. Many other components that we haven't talked about, but they are also logged by DMS, right? So you can extract the logs from the CloudWatch and output in your dashboard. I have no error at all, so this is nothing. But you can also extract the target error log. If, let's say, you can connect to your source database, and you can extract your source database, whatever the error that associated with some certain timestamp, you can also extract from there. So this is the CloudWatch dashboard that you can definitely create, and utilizing the matrix that is very important. Like we talked about the CDC latency, the resource utilization, you can create alarms based upon that, right? And then you can also have some certain signature that you need to watch along. For example, the suspended signature, right? So you can use your Lambda and to just retrieve more information about the task setting, about the database configuration, and then make it a very customized notification and send to your stakeholders, right? Other than that, there are multiple task states that you can subscribe to, which is leveraging the event bridge subscription, which you can see it is right here. Event subscription, right? So I have a task that got failed, I can directly get a notification using this notification, right? So I can do that as well.
Yeah, that's awesome. A lot of good visibility there.
Yep, this is everything that you can leverage. You can do consolidation. You can do integration. Everything listed here is just for you to be able to, automatically track the status and also have a better view and better visualization on what's going on in terms of the replication.
Yeah. So real quick, I think I think this is getting close to the end of our session here. We got one question from Perry. It says, if I clean up the logs from DMS storage, for example, I'm running out of storage space, right? We're talking about that metric here earlier. So if I clean up the logs from DMS storage, will that remove them from CloudWatch Logs as well?
No, it is separate. So you can say to just clean the logs from the disk, and CloudWatch has already got the logs exported. It has been there unless you definitely set the rotation or clean CloudWatch logs manually. Unless you do so, it will be just in the CloudWatch. You can still keep track on what's going on from there.
Got it. Okay, thanks. So yeah, no worries about, you can clean up the DMS instance and they'll still be in CloudWatch.
Yes, exactly. So last topic that I want to touch on is the rolling back strategy, right? So we talk about migration, this is great, but for contingency, what if, after cutover, something bad happens to the target database if I want to roll back, right? So what are the strategies that I can apply? But once again, this is for contingency. It is mainly important that you need to test ahead before cutover, right? Don't rely on some random spot check and then you go ahead to do the cutover and finally see the application goes down, right? So this is definitely not a good practice. One feature that you can leverage in DocumentDB, and this is the clone, like we said, right? So you can clone your DocumentDB and do the test with your most recent data, right? And then if find out anything in the clone, let's say if you messed up the clone with some index creation, or it has some bad data that got inserted into the clone for testing purpose, it doesn't impact the source, which is the one DMS continually inserting, updating, deleting the data into. It doesn't mess up there, right? So you can use the clone to basically test intensively, right? Test the features that your application should support and test the performance in the target. But what if, let's say, I haven't tested one edge case and it is breaking my application? What I can do for falling back, right? So normally speaking, you basically have the three strategies here, but more you can see from this blog post linked here, right? You can go search this blog post. It has more strategies, but normally speaking, the three strategies. First of all, if you just directly see the issue after the cutover, you haven't go live yet, right? So you can directly go back. This is the easiest way. But you find it out after maybe several days already, right? Then you're going to lose the data, if you fail
Right.
back. That is the reason why people may want to do a rise during the cutover phase, at least let's say for a week or several weeks, depending on your timeline. Do a rise can be helpful to just if this is going down, I can do this. If this is going down, I can have another live database. Forward, this is basically have a copy of the original database and fall over back to that. The reason why you may potentially do that is what if there is some issue during this replication, right? And some data got messed up here. You still have a consistent database, originally live and good, right? So this
Got it.
is fall forward. Um, for DMS to help you to do that, uh, DocumentDB has the change string for DMS to parse. You can parse those change streams to S3, and from S3 you can load to MongoDB, for example. Or you can have your own script to parse the change streams from DocumentDB and then load to MongoDB.
Got it. Awesome. Wanshan, this is great information, and I mean, I learned some new things today, and I'm sure all of our listeners and viewers have learned a lot. So really, really appreciate your time and sharing this with us.
Thank you. Thank you so much.
Yeah. All right, and I would like to thank all of our viewers who joined us today. Again, thank you for your time. Have a good rest of your day or evening, and we will be back next month, our third Thursday of every month. We have DocumentDB Insider Hour, 10 a.m. Central U.S. time. So, with that, thanks again, and have a good day.
Bye. Bye,
Bye.
everyone. Thank you. Have a good day.